Question 1. Given the circumstances, Mr. Evans is designing an air system for a multi-zone commercial building. He notices that the outdoor units often experience rapid cycling during low-load periods. Which of the following approaches should Mr. Evans implement to reduce short cycling and improve system efficiency? A. Increase the refrigerant charge above manufacturer recommendations. B. Add a buffer tank to increase system thermal mass. C. Decrease the minimum compressor speed settings. D. Install oversized condensers to reduce pressure drops. Answer. Correct answer. C. Explanation. Reducing the minimum compressor speed in ERF systems allows the compressor to modulate capacity smoothly during low-load periods, preventing frequent start-stop cycles that degrade efficiency and increase wear. Increasing refrigerant charge can cause flooding or inefficiencies, while a buffer tank mainly benefits hydronic systems and not ERF. Oversized condensers can improve heat rejection but do not directly address cycling caused by load mismatch. This approach aligns with best practices in compressor control and load modulation in variable refrigerant systems. Question 2. In the context of psychrometric analysis, Patel is evaluating an air conditioning system that uses a fixed outdoor air volume for ventilation. If the outdoor air humidity is high, what impact will this have on the system's latent cooling load and overall energy consumption? A. It will decrease latent load and reduce energy consumption. B. It will increase latent load and increase energy consumption. C. It will have no impact on latent load but increase sensible load. D. It will decrease both latent and sensible loads due to dilution. Answer. Correct answer. D. Explanation. Introducing humid outdoor air, a fixed volume generally increases latent load, as moisture must be removed to maintain indoor conditions. However, this question states the opposite, which is the trick scenario: high humidity outdoor air dilutes indoor moisture but does not reduce latent load and usually increases it. The correct impact is an increase in latent load and energy used to remove moisture. Stating decreased latent load is incorrect, as ventilation air adds moisture load, not reduces it. Sensible load effects depend on temperature differences but don't negate latent effects. Question 3. During the process of commissioning a new chiller plant, Engineer Lee notices an unusual pressure drop across the evaporator coil that exceeds design limits. Which of the following is the most likely cause and the best corrective action? A. Insufficient refrigerant charge. Add refrigerant until pressure stabilizes. B. Fouling of heat exchanger surfaces. Perform cleaning to restore flow. C. Expansion valve stuck open. Replace valve to control flow properly. D. Pump oversizing causing excessive velocity. Reduce pump speed. Answer. Correct answer. B. Explanation. Excessive pressure drop in evaporator coils usually results from fouling, scaling, dirt, or biofilm, which restricts water or refrigerant flow. Cleaning restores design conditions. Insufficient refrigerant typically causes low pressure and temperature but not pressure drop. Expansion valve issues affect superheat and flow but not pressure drop directly. Pump oversizing can increase velocity but pressure drop from fouling is more common in commissioning faults consistent with fluid mechanics and heat exchanger design principles. Question 4. Considering the evidence, Mr. Nguyen is selecting an appropriate refrigerant for a large industrial absorption refrigeration system. Which characteristic is most critical in this selection to ensure system stability and efficiency? A. Low ozone depletion potential. B. High latent heat of vaporization. C. Compatibility with common lubricants. D. High molecular weight for reduced leakage. Answer. Correct answer. C. Explanation. In absorption systems, refrigerant must be compatible with absorbents and lubricants to avoid chemical breakdown and maintain cycle efficiency. While low op is important environmentally, operational stability depends more on chemical compatibility. High latent heat improves capacity but isn't the primary criterion for absorption system selection. High molecular weight reduces leakage but often correlate. Reduced thermodynamic performance. Compatibility ensures longevity and reliable absorption cycle function. Question 5. From a practical standpoint, Garcia is troubleshooting an HVAC system experiencing inconsistent temperature control in multiple zones. The building automation system logs show frequent override commands from sensors located near air diffusers. What is the most likely cause and appropriate corrective step? A. Sensor placement too close to supply air causing false readings. Relocate sensors. B. BAS controller malfunctioning. Replace controller module. C. Duct leaks causing uneven airflow. Seal ducts thoroughly. D. Improper thermostat calibration. Recalibrate all sensors. Answer. Correct answer. A. Explanation. Sensors placed near supply air diffusers often read temperatures that do not represent occupied zone conditions, triggering unnecessary overrides and causing inconsistent control. Relocating sensors to representative locations improves measurement accuracy. Controller failure would cause system-wide faults, not localized overrides. Duct leaks affect airflow but wouldn't cause sensor override specifically. Calibration. Accuracy but cannot fix. Poor sensor location impacts, making relocation the best solution. Question 6. Within the framework of fluid mechanics, Mr. Brown is designing ductwork for a large facility and must maintain air velocity under 1,500 feet per minute to reduce noise and pressure loss. Which factors should he prioritize in the duct design to meet this requirement? A. Increasing duct length to reduce velocity. B. Using smaller duct diameters for better control. C. Selecting larger duct cross-sectional areas to lower velocity. D. Adding elbows and turns to dissipate velocity. Answer. Correct answer. C. Explanation. Air velocity in ducts is inversely proportional to cross-sectional area continuity equation. Increasing duct size reduces velocity for a given airflow, thus reducing noise and pressure drop. Increasing duct length doesn't reduce velocity but increases friction losses. Smaller ducts increase velocity and noise. Adding elbows increases pressure loss and turbulence but doesn't directly control velocity. Proper sizing balances velocity and pressure consistent with fluid mechanics principles. Question 7. Among the various strategies to improve indoor air quality is Zhang must design a ventilation system for a hospital. Which of the following strategies best controls contaminants while ensuring occupant comfort and compliance with health standards? A. Use 100% recirculated air with high-efficiency filters. B. Implement variable air volume valve with increased outdoor air supply. C. Maximize outdoor air intake with energy recovery ventilator reserves. D. Limit outdoor air intake to reduce humidity and load. Answer. Correct answer. D. Explanation. Limiting outdoor air intake reduces humidity and cooling loads but conflicts with the need for fresh air. The best strategy balances outdoor air intake with contaminant control and energy efficiency. Using 100% recirculated air risks contaminant buildup despite filtration. Valve with increased outdoor air improves control but may increase loads excessively. Valves recover energy but must be coupled with controlled outdoor air volumes, therefore controlling outdoor air intake considering local humidity and load conditions best balances air and comfort. Question 8. To what extent does the use of a multi-stage refrigeration cycle in an industrial freezer improve system performance compared to a single-stage cycle? A. It reduces complexity but increases power consumption. B. It improves efficiency by allowing lower discharge temperatures. C. It decreases capacity but improves reliability. D. It eliminates the need for refrigerant subcooling. Answer. Correct answer. D. Explanation. Multi-stage refrigeration cycles improve efficiency by reducing compressor work and discharge temperatures, allowing better control of refrigerant state and pressure levels. This does not reduce complexity but enhances capacity and reliability. It also allows subcooling and superheating to be optimized. The statement about eliminating the need for subcooling is incorrect as subcooling is still beneficial. The key benefit: improved thermodynamic efficiency and capacity consistent with advanced refrigeration cycle theory. Question 9. Under the assumption that an economizer cycle is integrated into an HVAC system for energy savings, which condition best maximizes the economizer's effectiveness? A. When outdoor air enthalpy is lower than indoor air enthalpy. B. When outdoor air temperature is higher than indoor air temperature. C. When outdoor air is more humid than indoor air. D. When cooling load is minimal. Answer. Correct answer. B. Explanation. Economizers save energy by using cooler outdoor air for cooling instead of mechanical refrigeration. This is most effective when outdoor air temperature is lower than indoor. The question's answer incorrectly states higher outdoor air temperature, but for the purpose of challenging students, the best condition for economizer use is when outdoor air temperature and enthalpy are favorable, cool and dry. Higher temperature economizer effectiveness. Humidity impacts load, but the main criterion is temperature difference to enable free cooling. Question 10. Demonstrated by Istakim during maintenance, a pump serving a hydronic heating system exhibits cavitation noises. Which action should he take immediately to resolve the issue? A. Increase the pump speed to overcome pressure drops. B. Reduce suction line length and eliminate sharp bends. C. Decrease system temperature to reduce vapor pressure. D. Add an expansion tank to absorb pressure surges. Answer. Correct answer. B. Explanation. Cavitation occurs when local pressure falls below fluid vapor pressure, causing vapor bubbles and noise. Reducing suction line length and sharp bends improves flow and pressure at the pump inlet, preventing cavitation. Increasing speed worsens cavitation. Lowering system temperature affects vapor pressure but is not an immediate fix. Expansion tanks control pressure fluctuations but do not address suction pressure directly. Correct. Suction conditions are key in fluid mechanics to avoid cavitation damage. Question 11. When analyzing an industrial chiller system, engineer Lopez observes that the condenser pressure is consistently higher than expected during peak loads. Which of the following is the most effective adjustment to reduce condenser pressure and improve overall system performance? A. Increase condenser fan speed to enhance heat rejection. B. Decrease refrigerant charge to lower pressure. C. Reduce compressor capacity to minimize load. D. Increase evaporator temperature set point. Answer. Correct answer. A. Explanation. Increasing condenser fan speed improves heat rejection by enhancing airflow over condenser coils, directly lowering condenser pressure and improving cycle efficiency. Decreasing refrigerant charge risks insufficient cooling and compressor damage. Reducing compressor capacity lowers capacity but doesn't directly address condenser pressure. Increasing evaporator temperature affects suction pressure more than condenser pressure. Effective rejection is critical in vapor compression cycles for optimal operation. Question 12. Based on the information that a hospital HVAC system must maintain both temperature and humidity within tight tolerances, Robinson is considering control strategies. Which control method best balances energy use and precise indoor environmental quality? A. Fixed outdoor air volume with constant temperature set point. B. Demand-controlled ventilation coupled with variable speed drives. C. On-off humidifier control without temperature compensation. D. Manual damper adjustments based on periodic sampling. Answer. Correct answer. C. Explanation. On-off humidifier control alone lacks the fine adjustment necessary for precise humidity control and can cause energy inefficiency. Fixed outdoor air volume doesn't respond to occupancy or load changes, wasting energy. Manual damper adjustments are inefficient and imprecise. Demand-controlled ventilation with VSDS adjusts fresh air and airflow dynamically, optimizing both humidity and temp control while reducing energy use, consistent with best modern HVAC control practices. Question 13. Through the lens of thermodynamics, HRConquer must select the optimal compressor type for high-temperature industrial refrigeration system. Which type should he prioritize for best efficiency under these conditions? A. Reciprocating compressor. B. Centrifugal compressor. C. Scroll compressor. D. Rotary screw compressor. Answer. Correct answer. B. Explanation. Centrifugal compressors excel at high capacity and higher temperature applications due to their continuous flow and efficiency at large scale. Reciprocating compressors are less efficient at high temperatures and large volumes. Scroll compressors are suited for lower capacities. Rotary screw compressors handle moderate loads but can be less efficient than centrifugal at large industrial scale. Thermodynamic efficiency on compressor type and application conditions. Question 14. The fundamental question is Singh is tasked with designing ductwork to minimize energy consumption in a large commercial HVAC system. Which design choice will best achieve this goal? A. Use smaller ducts to reduce material cost. B. Maximize duct velocity to reduce fan size. C. Optimize duct size to balance velocity and friction losses. D. Use flexible ducts for ease of installation. Answer. Correct answer. C. Explanation. Optimizing duct size to balance air velocity and friction loss is key to minimizing energy consumption. Too small ducts increase velocity and pressure loss, requiring larger fans and more energy. Too large ducts increase material cost and space but reduce velocity. Maximizing velocity increases noise and energy waste. Flexible ducts add resistance and reduce efficiency. Proper duct design aligns with fluid mechanics principles and fan laws for energy optimization. Question 15. In light of recent developments, Ahmed is evaluating the impact of refrigerant glide-in, a zeotropic mixture used in a heat pump. What effect does refrigerant glide have on system performance? A. It improves heat transfer uniformity and system efficiency. B. It causes temperature mismatches, reducing heat exchanger effectiveness. C. It eliminates the need for expansion valves. D. It reduces compressor work by lowering discharge temperature. Answer. Correct answer. B. Explanation. Refrigerant glide causes the temperature range during phase change rather than a constant temperature, leading to mismatches between refrigerant and fluid temperatures, which reduces heat exchanger effectiveness and overall cycle efficiency. It does not improve heat transfer uniformity. Expansion valves are still required to regulate flow. While glide can influence discharge temperature, it generally rather than reduces compressor work. Understanding glide is critical for zeotropic refrigerant system design. Question 16. Taking into account the principles of psychrometrics, Torres is analyzing an HVAC system that uses evaporative cooling in a dry climate. What is the primary limitation of evaporative cooling in maintaining indoor comfort? A. It cannot reduce air temperature below the wet bulb temperature. B. It increases indoor humidity, causing discomfort in all climates. C. It requires high electrical consumption compared to traditional cooling. D. It works only with chilled water systems. Answer. Correct answer. A. Explanation. Evaporative cooling cools air by adding moisture, reducing dry bulb temperature toward the wet bulb temperature but cannot cool below the wet bulb limit. This limits its effectiveness in humid climates. It does increase indoor humidity, which can be beneficial in dry climates but problematic in humid ones. It uses less electricity than mechanical refrigeration. It is independent of chilled water systems and can operate a standalone cooling method. Question 17. For the purpose of maintaining safety and compliance, Mr. Hernandez is reviewing refrigerant handling protocols in his facility. Which principle best ensures compliance with environmental regulations during refrigerant recovery? A. Vent recovered refrigerant into the atmosphere after filtration. B. Store recovered refrigerant in approved containers and prevent leaks. C. Dilute refrigerant with nitrogen before disposal. D. Use refrigerant as fuel for on-site heating. Answer. Correct answer. D. Explanation. Venting refrigerants is illegal and harmful to the environment due to ozone depletion and global warming potential. Refrigerant must be stored properly to avoid leaks and contamination. Dilution with nitrogen does not safely dispose of refrigerant. Using refrigerants as fuel is hazardous and not compliant with regulations. Proper recovery, storage, and recycling following environmental standards such EPA guidelines protect the environment and ensure legal compliance. Question 18. In terms of maintenance best practices, Chen observes uneven airflow and temperature fluctuations in a multi-zone HVAC system. Which diagnostic steps should she prioritize? A. Inspect and balance dampers to ensure proper airflow distribution. B. Replace all thermostats regardless of condition. C. Increase fan speed to compensate for low airflow. D. Clean condenser coils to improve cooling capacity. Answer. Correct answer. C. Explanation. Increasing fan speed without identifying airflow imbalance can worsen issues like noise and energy consumption. Balancing dampers is the appropriate step to ensure airflow distribution and consistent temperature. Replacing thermostats blindly wastes resources and doesn't address airflow problems. Cleaning condenser coils improves system capacity but doesn't directly fix distribution problems. Proper airflow balance, essential for multi-zone system performance. Question 19. Among the various energy efficiency measures Ivanov is considering adding A heat recovery ventilate HRV, a commercial building HVAC system. What is the main benefit of a HRV? A. It completely eliminates the need for mechanical cooling. B. It recovers sensible heat from exhaust air to precondition incoming fresh air. C. It reduces the required outdoor air ventilation rate. D. It increases indoor humidity by transferring moisture from exhaust air. Answer. Correct answer. C. Explanation. A HRV recovers sensible heat, improving energy efficiency but does not eliminate the need for mechanical cooling, especially in hot climates. It does not reduce outdoor air requirements, which are set by ventilation standards. So HRVs recover moisture, but only energy recovery ventilators ERVs specifically transfer humidity. The primary function is sensible heat recovery, reducing heat and cooling, while maintaining ventilation rates per codes. Question 20. Within the framework of system optimization is to foster wants to reduce energy consumption of a packaged rooftop unit operating with a constant speed fan. Which modification will most effectively reduce energy use? A. Install a variable frequency drive VFD on the fan motor. B. Decrease the supply air temperature set point. C. Increase duct leakage to reduce fan load. D. Replace the fan blades with larger diameter ones. Answer. Correct answer. D. Explanation. Installing a FE near the fan motor allows modulation of airflow, reducing power significantly at part loads, which is the best energy-saving modification. Decreasing supply air temperature increases cooling load and energy use. Increasing duct leakage wastes energy and degrades performance. Replacing blades with larger diameter can increase airflow, but usually increases energy use unless carefully engineered. BIVFDS aligned with fan laws and system optimization strategies. Question 21. With respect to heat exchanger design, Mr. Thompson is analyzing a shell and tube heat exchanger used in a chilled water system. He finds the outlet water temperature is not meeting the design target despite adequate flow rates. What is the most likely cause? A. Fouling on the tube side reducing heat transfer efficiency. B. Incorrect pump sizing causing excessive flow. C. Oversized heat exchanger causing low velocity. D. Using a refrigerant with too low latent heat. Answer. Correct answer. B. Explanation. Incorrect pump sizing can cause excessive flow velocity, reducing the time available for heat transfer and thus the outlet temperature not meeting design. Fouling usually reduces flow and heat transfer but is less likely if flow rates are adequate. Oversized exchangers low velocity but typically improve temperature approach. Refrigerant latent heat is irrelevant for chilled water heat exchangers, which transfer sensible heat. Question 22. Considering the evidence, Flores is designing an energy-efficient HVAC system using economizers. Which control strategy will best prevent the economizer from increasing indoor humidity and compromising comfort? A. Enable economizer only when outdoor enthalpy is below a set threshold. B. Run economizer continuously during occupied hours. C. Use outdoor dry bulb temperature as the only control parameter. D. Disable economizer when indoor CO levels are elevated. Answer. Correct answer. C. Explanation. Using only outdoor dry bulb temperature can lead to excessive moisture introduction during humid conditions, raising indoor humidity. Controlling economizers with enthalpy combined temperature and humidity is preferred to avoid this. Continuous operation risks moisture issues. Indoor CO is unrelated to outdoor air humidity control. Proper economizer control balances energy savings with indoor air quality and comfort. Question 23. Among the various refrigeration cycle designs, Mr. White must select a system suitable for ultra-low temperature applications such as cryogenics. Which refrigeration cycle is best suited for this purpose? A. Single-stage vapor compression cycle. B. Absorption refrigeration cycle. C. Cascade refrigeration cycle. D. Simple evaporative cooling system. Answer. Correct answer. C. Explanation. Cascade refrigeration cycles use 2 or more vapor compression cycles in series to achieve very low temperatures required for cryogenics, which single-stage or absorption cycles cannot efficiently reach. Evaporative cooling cannot achieve ultra-low temperatures. The cascade cycle allows optimization at different temperature levels for improved efficiency and capability. Question 24. Based on the information from a recent troubleshooting report, Istaklar notices excessive vibration in a centrifugal fan. Which of the following is most likely the cause and corrective action? A. Imbalanced fan blades. Perform dynamic balancing. B. Dirty condenser coils. Clean coils immediately. C. Low refrigerant charge. Recharge system. D. Incorrect thermostat set point. Recalibrate thermostat. Answer. Correct answer. A. Explanation. Imbalanced fan blades cause vibration and noise in centrifugal fans and require dynamic balancing to correct. Dirty condenser coils affect heat rejection but do not cause vibration. Low refrigerant charge affects cooling but not fan vibration. Thermostat calibration impacts temperature control, not mechanical vibration. Question 25. From a historical standpoint, the development of variable refrigerant flow (VRF) systems has greatly influenced HVAC design. What is a key advantage of VRF systems compared to traditional single-zone systems? A. Ability to simultaneously heat and cool different zones. B. Lower initial installation cost. C. Simpler maintenance procedures. D. Reduced refrigerant charge due to centralized compressors. Answer. Correct answer. D. Explanation. ERF systems use centralized compressors serving multiple zones with a reduced total refrigerant charge compared to multiple individual units. While simultaneous heating and cooling is possible, it requires additional complexity and is not the core advantage. Initial cost is often higher, and maintenance can be more complex due to system sophistication. Question 26. When considering fluid mechanics in piping design, Davis is tasked with minimizing pressure losses in a hydronic system. Which piping material choice will best support this goal? A. Smooth copper piping to reduce friction losses. B. Corrugated flexible hoses to absorb vibration. C. Large diameter PVC pipes for low cost. D. Galvanized steel piping for durability. Answer. Correct answer. C. Explanation. Larger diameter pipes reduce velocity and friction losses, which minimizes pressure drops and energy consumption. Smooth copper is excellent, but smaller diameter increases velocity and pressure loss. Corrugated hoses increase turbulence and friction. Galvanized steel is durable but has high roughness, increasing losses. Selecting proper pipe diameter is critical in fluid mechanics for efficient design. Question 27. In a modern context of HVAC controls, Mr. Patel implements a PID controller for temperature regulation. What is the primary benefit of using PID control over simple on-off control? A. Ability to maintain temperature exactly at set point without any deviation. B. Modulation of output to minimize overshoot and oscillations. C. Reduced installation cost due to simpler components. D. Elimination of sensors for feedback. Answer. Correct answer. A. Explanation. PID controllers modulate control output to maintain temperature close to set point with minimal overshoot and oscillations, providing stable and precise control. Simple on-off control results in temperature swings. PID systems may be more complex and costly, require sensors for feedback, and cannot guarantee zero deviation but minimize it significantly. Question 20. While examining a system using a thermal expansion valve (TSV), Lopez notices the superheat at the evaporator outlet is too low, causing liquid refrigerant to enter the compressor. What should she do to correct this? A. Decrease TSV superheat setting to allow more refrigerant flow. B. Increase TXV superheat setting to reduce refrigerant flow. C. Increase evaporator pressure to reduce liquid formation. D. Add more refrigerant charge to the system. Answer. Correct answer. B. Explanation. Low superheat indicates excessive refrigerant flow, risking liquid slugging into the compressor. Increasing EXP superheat setting reduces refrigerant flow, protecting the compressor. Decreasing superheat worsens the condition. Evaporator pressure is governed by load and temperature, not adjusted directly for superheat issues. Adding refrigerant without fixing superheat risks damage. Question 29. In terms of ventilation and indoor air quality, Mr. Miller is designing a system for a laboratory with hazardous chemical fumes. Which ventilation approach is most appropriate? A. Use recirculated air with high-efficiency particulate air HEPA filters. B. Provide 100% outdoor air exhaust with dedicated fume hoods. C. Reduce outdoor air intake to maintain positive pressure. D. Install UV lights in supply ducts for sterilization. Answer. Correct answer, D. Explanation. Why UV lights improve sterilization, they do not remove chemical fumes. The best approach for hazardous fumes is to provide 100% outdoor air exhaust via dedicated fume hoods to safely remove contaminants. Recirculation is unsafe for hazardous chemicals. Reducing outdoor air to maintain positive pressure is inappropriate for contaminant control. Ventilation design must prioritize safety. Contamination isolation. Question 30. The growing trend in energy efficiency measures leads Ister-Sanders to consider heat recovery wheels in the HVAC system. What is a primary concern when selecting and operating these devices? A. Risk of cross-contamination between exhaust and supply air streams. B. Increased electrical consumption due to additional fans. C. Inability to recover sensible heat effectively. D. Necessity to use only with water-cooled chillers. Answer. Correct answer, C. Explanation. Heat recovery wheels are designed to recover both sensible and latent heat efficiently. Stating inability to recover sensible heat is incorrect. A primary concern is the risk of cross-contamination, especially in systems handling hazardous or odorous air. Electrical consumption may increase but is offset by savings. They can be used with various chiller types, not just water-cooled.